much, everybody. And thank you, Martin, for that introduction. Okay, we have slides. Fantastic. So I will just call out for the slides to be advanced, but let's just keep it there just for 1 second. So let me just give you just a very brief overview as to why I am talking to you. So first and foremost, I am delighted to be part of the kind of steering committee for what we're doing here with Brighton AI. And to try and help get this off the ground, which I'm very excited to do. I'm a latecomer to that party, but really delighted to be in the team with Martin, Claire, BC, etc. For myself personally, I have been in artificial intelligence for literally my entire career. My degree is in artificial intelligence, and I graduated in 1990 from Edinburgh University. I can obviously sharp intakes of breath from the audience. You can't quite believe that I graduated all that time ago, but I did. And I've been working as a data scientist, as an AI developer, as an entrepreneur, and latterly as a CTO and consultant in the field of data science and AI for whatever that is now, getting on 35 years. Clearly, the subject matter was a little bit different when I started, but the principles were the same. So when I was at university, neural networks were in the process of being invented and rolling out. Okay, can we have the next slide, please? Yeah, let's have some hype just to begin with. Why not? Let's move on again. Okay, just some numbers to start off with. So the turnover of AI companies in the UK is currently reckoned to be around 42 billion a year. There's been an equivalent amount of funding into AI companies in that same period. Now, obviously, you always get the giants, the 300-pound gorillas that suck up a great deal of that money. And I have to admit that Google DeepMind is included in those figures, which does skew things a bit. But nevertheless, it's a big sum. What is interesting to me, and interesting, I think, for this group in Brighton AI, is there's reckoned to be well over 2,500 startups specifically in AI at the point that this survey was done, which is the start of this year. I reckon that figure's gone up quite dramatically since then. And I'd really like to see more of that happening in Brighton. And anything that this group can do to promote that, I think, is a really great thing. In short, it's hot. Let's move on. Thanks. Just a quick comparison for Martin and his Brighton and beyond side of things, and startups specifically in Cambridge. Again, this is start of 2023, so these numbers will have ramped up quite considerably. But at the start of this year, nearly 100 companies, 100 companies in Cambridge are AI companies first and foremost, and the vast majority of those is in the startup space. Totaling a turnover of 2.4 billion already. Clearly, that's coming mainly from this end rather than the startups, but nevertheless. Okay, and on again. And what is AI? Okay, so here we go. So Martin is acting as the ringmaster for this evening. I am effectively acting as the fluffer for this group. So I've been asked to give a kind of background on AI, and I appreciate we don't really understand this audience terribly well. I guess there are some people in this audience who are real experts in AI, and anything I say is going to feel pretty basic. There are others of you who have a real interest in AI, but don't really understand the technology at all. So trying to pitch this could be a little tricky, but we'll see what we can do. So first of all, let's get our terminology right. We talk about being data scientists. Very few people, except the ones that suddenly got into AI this year, call themselves AI experts. We tend to refer to ourselves as data scientists. And data science is a really broad church. It includes everything that you do with a spreadsheet for a start off, let alone everything that you do across business intelligence inside an organization. Data analyst jobs, first and foremost, are leading you through to data science. Its statistics are a core part of data science. However, within that, we have the area of machine learning, which is using probabilistic algorithms to generate predictions or classifications of data that you find really hard to do with classic statistics. I'm going to talk a little bit more about that in a minute. But essentially, when you go from the statistical data through to machine learning, you're starting to deal in probabilities rather than deterministic outcomes. And then within that, we have this field of neural networks that has grown up across the last 35 years, but has really become massively prominent in well, as it's come to everybody's attention in the last year or two, certainly. And a lot of the in-depth work with artificial intelligence over the last 15 years has been really focused on the development and use of neural networks. Again, I'm going to give you a very short primer on what they are in a second. Neural networks and deep learning are essentially the same thing. So when people talk about deep learning, what they're talking about is a neural network which has more layers. I'll explain that in a second, but essentially a complex neural network is deep learning, and a shallow or less complex neural network is a neural network. So when people talk about deep learning, they are talking about neural networks, they are talking about machine learning. And then finally, when we get to artificial intelligence, we've got the woolliest definition of the lot. So my definition of what artificial intelligence is all the stuff that we think only humans should be able to do, broadly. And it's a moving target. So if we go way back to the Stone Ages, when I was at university studying artificial intelligence, I was studying the use of neural networks to recognize characters from images. And my professor at the time had started a business, and that business had sold his software to the UK government. And he was up in arms because he hadn't realized what it was going to be used for. So back at that point, we had the miners' strikes, and a chap called Arthur Scargill was organizing flying pickets to move around the country to blockade access to mines unexpectedly in order to disrupt the production of coal, which back then was really big industry. The police had started using this technology in cameras on motorways in order to track the number plates of the flying pickets so that they could get to the mine before the flying pickets and stop them from blocking mine access. That was state-of-the-art artificial intelligence. These days, every time you drive in and out of a car park, your registration number gets read and you don't think twice about it. Do you think of that as artificial intelligence? I doubt it, frankly. It's a moving target. So back then it felt that reading a number plate from an image or a video was something really that only humans could do. It was AI. Today, we're talking about the generation of text that is as good or better than we are capable of writing ourselves, or creating images that feel like only top quality artists should be able to produce them. That today is AI. In the future, that's going to seem quite mundane and the field will move on. Essentially, AI is trying to replicate the capabilities of human being, and whatever state of the art is where that category will stand. Okay, let's move on. Okay, I'm going to keep this short, but just to go through the basics. So this is a classic picture of a neural network. It's the foundation of everything that we're doing in modern artificial intelligence. Essentially, you've got a set of inputs going through the orange on the left. They go through a set of weighted nodes that vary the data and pass data according to the weights to different nodes before things pop out on the right-hand side of the blue with an answer. Now, when you start using a neural network, you'll put the data you want in and you'll get something out that's completely rubbish. So let's say you're using it to classify pictures of cats from the internet. When you first start passing it pictures of cats and dogs and people, it's going to get a jumble out the other end and mess it up completely. What we do is use a feedback mechanism, backpropagation through the nodes, which changes the weighting, these W's on that image, which causes the input data to bounce around like a pinball in different directions depending on those weights. Over time, as you get an error out the back, you see the size of that error and use that error with an algorithm to change the weights in your network. You do it again, you do it again, and over time, you start to only pop out pictures of cats from the top node and only pop out pictures of dogs from the bottom node, and it works. This is a learning mechanism, therefore. It's never going to be perfect. You might get it to 85, 90% accuracy and feel that you've done well. You could spend a year then getting it to 93% accuracy and the rest of your life getting it to 100% accuracy. But it's pretty good. It works well. It works as well as a human can, working with edge case images where you can only see a leg and you can't see if it's a dog or a cat or whatever. That essentially is the working of a neural network. Bunch of calculations. It's basically mathematical formulas, passing data in, transforming that data over time until you get classified output out the other side, and then using a feedback mechanism to improve that. And this is basically, at least in concept, the same way that a human biological neuron works, that we have all of these connected neurons in deep layers that allow us to learn over time by formalizing the weightings of these neurons. A deep learning network is one where there are more layers in the middle. Basically, this is a 2-layer network. It's very shallow. A deep learning network might have 20 layers. That's really the only difference. Well, some tech, but it's the biggest difference. Skip on, please. Okay, and generative AI. So generative AI is what we've been really excited about this year. It's what's caused this tsunami of interest in AI, a field that I've been part of and following for most of my adult life, and actually now appears to be one of the hottest things around. I've been telling people for a long time it would happen, and it seems to have happened. Generative AI is based on neural networks. So it uses a particular type of neural network called a transformer. I won't go through the technical details of what the differences are in transformers compared to recurrent networks or whatever, but nevertheless, it is a form of neural network. So those basic principles are the same. It has some techniques associated with it that have made it exceptionally good, really quite dramatically, impressively, incredibly good at doing things like generating text. The principle of a large language model, which is the kind of the primary contact that all of us will have with generative AI, is that it predicts what the next most likely word is based on the context it's been asked to work with. It has no understanding of what it is you actually asked or the back-end meaning of that. It's not reasoning in any measurable way. It is simply using mathematical weightings in its neural network to decide what the next most appropriate word is for the question that it was asked. So it uses context, and that's what makes it feel so human-like, so artificially intelligent. The big neural networks like GPT are very impressive because they're incredibly expensive. So the training process for these large language models is really huge. There are no figures out there because OpenAI is the least open company you'll ever find. But it's reckoned that it's somewhere in the region of $100 million that it costs to train GPT-4. They have quite a lot of money. Microsoft's put 12 billion into them in total over the last few years. And they're actually making about 2 billion a year in direct revenue from OpenAI now. So they're starting to motor, but it's a huge cost behind this. And that's why we have no sign of GPT-5 coming at the moment. They're talking about GPT 4.5. And that's interesting because GPT, it seems, actually isn't one model at all. It's a collection of large language models working in a multimodal manner that are linked together so that you ask one query, it's then doing directed calls through multiple models beneath that, which is a much more cost-effective way to operate and a way that allows them to incrementally improve over time. So, and I think that is what we're likely to see from GPT specifically over time. This incremental improvement. We're starting to see the introduction of image analysis to use as context, which is another model that they've bound into it. That's available now through Bing Chat and recently through an extension on OpenAI. We're starting to see various other capabilities with the plugins and the connectors that they're building as they're building an ecosystem around this. It's a very impressive system. However, as impressive as it is, my personal belief is that the big models like GPT are not the future, or at least they're not all of the future. Back in the early days of large language models, which was what, about 8 months ago, really, in terms of commercial awareness, I was of the opinion that Microsoft, Google, OpenAI, and a couple of others were going to just clean up completely, and they were going to take all of the revenue from this. Because startups essentially that are using GPT don't seem to have a lot of there's no moat. You know, if you can replace one model with another model. You're building a front end onto that system. It doesn't give you a lot of traction and competitive advantage. Actually, over the last few months, I've seen a vast upswelling in open source development in large language models, and really, really promising development. So, hello, in this picture here, where you've got GPT-4 as the big one in the room, you have a number of other really interesting models around it. So you've got Google's Palm 2, which not surprisingly is the second biggest, but you've also got Llama, which was an open source release from Meta, Facebook, which is commercially usable with a few restrictions and is really capable. You've got Falcon, which comes from Saudi Arabia. You've got Claude, which is, and Chinchilla, which are commercial organizations, and various others coming up from there. The Llama 2, it should be, not Llama 1. Llama 2 is particularly interesting because of that open source capability. And I'm seeing specialized models with a much smaller footprint starting to come out with really great rapidity. This is important. It's important because I think the future of these models is not big generic models that try to be everything to all people. I think it's small specialist domain expert models that I believe we might even see running on our mobile phones within 2 years, that the footprint and the computational cost of running them is coming down so rapidly that we can run them on a really small footprint. Might still cost a lot of money to train them, but to actually operate them might be a lot less. Okay, let's move on. Okay, just back to basics. So AI, a primer is what we're doing. So let's just talk about the difference. So we're not writing software per se when we're creating AI. I mean, actually, my team is a team of developers, and they're developer data scientists. So they are writing code, of course, every day. But there are some significant differences in the code that we write for artificial intelligence to the code we write for software. So we write software as a deterministic requirement to solve a problem. If it solves a problem, we should be able to prove that it solves the problem all the time. It's deterministic. That's not the case with artificial intelligence. AI models are stochastic or probabilistic. They solve the problem most of the time. They're much more like people. We don't always get it right. You know, we mostly get it right if we know what we're talking about. We don't always get it right. And AI is the same. And it's very different in how you can use AI and how you have to focus your efforts if you're using it in business because of this. The example I've got there is we're very unlikely to ever be able to work out how to write a program to drive a car using a massive series of if-then-else statements. You know, it's infeasible to think of a deterministic program that will accurately deal with every scenario using a deterministic software approach. But teaching a model how to drive is entirely feasible. Entirely feasible to the extent that if you go to San Francisco, you can in fact get in a robo-taxi today, and that the UK laws for self-driving cars change in 2025 to allow them on the road, just 18 months from now. I doubt if we'll actually see very many in 18 months, but the legal ability to drive them is in place very soon. Second, well, I've talked about the stochastic versus probabilistic. So software, either it works or it doesn't. You can test it. You can do your QA. It works or it doesn't. When we're doing quality assurance and testing on AI, we're using accuracy scores. We're using a confusion matrix to understand how good is it, precision, recall, etc., etc. We are working out what percentage accuracy it is. It's never going to be, very rarely going to be 100%. And when we write software, the artifact, the core thing that we're producing, the value we're producing is in the code that we produce. Whereas in AI, it's all about the data. It's all about curating that data, engineering that data, finding features in that data that are meaningful, and then running the model upon it. Okay, next slide, please. Okay, and light relief. So yeah, so So it is all about data, but people that basically think you get a bunch of data, you point an AI at it, and you get a valuable output. And that's particularly become the case this year with the rise of the large language model, where there is a prevailing belief that you can basically point an AI at any set of data and just ask it a question and it's going to work. It will, to an extent. It will work at a lower percentage than you would like it to, but it will sometimes work. It is always and remains the case that if you put garbage into any piece of software, then you're largely going to get garbage out again. And so that data engineering section is absolutely crucial to coming up with any quality solution. And really, this is where the effort and the growth is in the AI field. It's around understanding and engineering data more than anywhere else. Although you've got a really interesting layer of operationalizing AI, where a lot of AI is currently in research mode, as I'd call it, which is the software's not that great, it's a bit buggy, doesn't have a lot of quality assurance about it. MLOps is not as well understood a field as DevOps. So there's a lot of improvement that we're going to see in the next few years in the quality of management and production delivery of AI software. And then we definitely shouldn't forget the fact that there are legal, ethical, and security issues around use of AI that go beyond that of normal software, because we, particularly with neural network usage, one of the features of the system is that you can't really look inside it and understand how it made a decision. All those little neurons, the nodes with their weights, they don't lend themselves to understanding why an AI came out with a particular output based on a particular input. Now, that might not matter too much if you're trying to understand why it classified something as a cat or a dog. It might matter a lot if you were using it as your recruitment software and it decided that you were going to interview person A and not interview person B. And I'm sure you'll all have heard horror stories from the net around facial recognition software that was biased towards a particular color of face or the like because of the training data that it was given. Classic example is that certainly until very recently, if you asked one of the image generation tools like Midjourney to come up with pictures of a CEO, then it would come up with a list of pictures of middle-aged white guys. Now, it doesn't do that because it's inherently racist or biased, or misogynist. It does it because that actually is the data it was given, because actually most CEOs are sadly middle-aged white guys. So it just comes out with whatever it is you give it. But that bias and the way that can affect us in society is really important. And this thread that we have in Brighton AI around ethics, bias, and social responsibility, I think is absolutely crucial. And I think it's something that we can really contribute to in the thinking of AI in our communities and beyond, because Brighton has a lot to say about this. Okay, skip on, please. Okay, let's get back to some practicality. Can we use it? Yeah, let's go again. So this is a slide I use when I'm helping organizations to think about what AI can actually do for them. So I tend to classify AI solutions into three broad areas: automation, analysis and prediction, and optimization. So the first one in automation, thank you, is I get asked people to think, well, if you had a whole load of interns, what could you do with them? What could you do now that you couldn't do easily today? So the nature of an intern is that they've got a brain, you hope. They haven't got any domain expertise, but they're capable if you just teach them what it is you want them to do. So if you had a whole load of them, could you automate tasks that currently take a lot of manual effort, or that slow down experts in your organization and stop them from being as productive and efficient as they could be? And a lot of the large language models and generative AI solutions fit into that particular category, obviously. Analysis and prediction, classic machine learning requirement. So how do you improve decision-making in an organization? Does your data lend itself to being able to find insights about the way that you operate, whether that's your cost base, your manufacturing rate, your customer churn rate, whatever it might be, that allows you to understand better what the impact of your decisions might be, and therefore to take better decisions earlier. An organization I'm talking to tomorrow has a fantastic app that is used by IBS sufferers to help them manage their symptoms and to discuss with their clinicians what it is they're going through. And they have a very rich data set that they've built up over the last 8 years. And what we're trying to do is to build a predictive model that will allow the app to predict in advance when you're likely to have a relapse, an episode of IBS, which can be incredibly painful, land you in hospital, cost the NHS a lot of money, is life limiting for the sufferer, etc. So if we could find out that what you're eating, your activity levels, your qualitative scores on how you're feeling on any given day, if that kind of data could be used to predict 8 days in advance of an episode, it could actually allow the user to take action that would stop that from happening. Great example of a predictive model. And then the third batch is around optimization and quality. So how can I do things better? So looking at operational research problems, on-demand pricing, which airlines all use, all the things which allow you to get the most out of whatever resource it is you're working on. And broadly across any organization, when you look at where you could use AI machine learning, it's going to fall into one or more of these 3 categories. It's not, I would point out, all just about generative AI, despite the hype that we're seeing at the moment. Machine learning solves a lot of really hardcore problems as well. Skip on, please. And when you're going through a process of working out what the right artificial intelligence projects are in any organization, these are the 3 pillars that I ask people to focus on. First and foremost, start with the value. Don't do something just because it's cool. Do it because it has a return. Do it because you can see that it can actually improve your organization. Even if you're just building a pilot, do something that will make a difference. And so starting with value to you, value to the organization, is the only way to begin. The second of those circles is then actually feasibility, and feasibility is, can it be done? So physically, does the data lend itself to do that? Do you have enough data? Is that data of a high enough quality? And can you as an organization actually deal with this? So if something involves changing processes in the organization in order to get value from it, is the organization actually willing and ready to do that? And that actually, I find, doing consultancy into mid-sized organizations, that can be a really significant block all by itself. As soon as it goes out of the tech into how it affects the organization operation, you've got a problem, particularly if it's the CTO or chief engineer who's commissioning a project. The third circle is then the ethics and legal side of things, the advisability. Should it be done? And there are not that many rules in place in the UK, although they are coming. The EU AI Act has been passed and comes into force next year, which has all sorts of implications. But then there are the social and ethical implications inside your own organization as well. If implementing an AI solution actually led to the reduction of your development team by 25%, is that something that you want to do? Is that actually the right way forwards? It's not always necessarily just about the bottom line. And move on, please. And this, what we're describing here is the process that my company, Attercop, takes organizations through when we're looking at how we build a roadmap for AI and binding it into the organization. Take these 3 pillars, ideate what's possible, work out what is advisable, decide what is feasible, and together through those come out with a stack rank list of opportunities for AI in an organization, which get filtered and then built into a roadmap for deployment which should be costed, have ROI associated with it, effort levels, and start with the lowest hanging fruit, the smallest project that will deliver the biggest impact. Let's just skip lightly on. Thank you. And I will then finish this bit with the shameless plug. So my company does these things. So workshops to help organizations understand what AI actually does or can do for an organization, going through this ideation process, the development of strategy and roadmap to actually execute AI inside the organization, And then I have a data scientist delivery team who are building AI solutions, machine learning, predictive models, etc., who deliver to mid-sized organizations across the UK and a little bit further. I will leave it at that. Let's move on. Thank you. Okay, let's get back to some fun stuff. One more, please. What's going to happen? Well, I am just another guy, and I am sure your views of what might happen in AI next are just as relevant as mine. So I'm just going to give you a few of my thoughts about what I see at the moment. So first of all, the disruption is going to be huge, but the disruption is going to hit it is not going to hit the highly skilled jobs as much as people might still fear that it does. For example, I do quite a lot of AI due diligence for private equity firms and helping the private equity firm understand the effectiveness of data science and AI teams within the organization. What I tend to find when I talk to software development teams is that most of them are using Copilot solutions, so AI software development tools at some level. There's very few teams that aren't using them at all. A lot of teams I talk about are developing as much as a quarter of their code base using AI, coming from a position last year where they were developing almost none of it using AI. And that feels like we're heading towards, oh my God, that's it. 25% of all coding jobs are going to go in the next couple of years. I'm not seeing it like that, actually. What I find is that it is a great tool for senior good coders. It's a lot less useful for junior coders. So it improves efficiency and productivity for people who have got the years behind them and the experience. And actually, it just doesn't function as well. It doesn't fit into the processes of the juniors as well. So I don't see it as knocking out the whole tier of junior coders. When we look at legal, I do see it reducing the number of legal assistants that are required in an organization because information retrieval will be better, faster, more organized. But I see it improving the productivity of senior lawyers and not threatening their jobs. And I can continue through all jobs involving domain expertise. I'm seeing the same thing at the moment. It improves the lives of the experts. It's not really reducing the jobs of the people on that pathway upwards. It is reducing the paralegals, the admin requirements, the intern type requirements that come with that. And this is a McKinsey graph, and that kind of supports that as well. So the most highly susceptible jobs for being replaced by AI are in predictable, repetitive work. So we've got the robotics coming in at this end, data processing, data collection. So all those admin jobs, this is where AI can have a big impact. Almost the least impact is on everything to do with dealing with people. Funnily enough, our ability to have human interactions remains as important or more important than it's ever been. Few other line items just to finish on. The combination of AI and physical robotics, I think, is going to be huge. Again, that's borne out by McKinsey's graph here. Even if you put aside Elon Musk and his army of terrifying humanoid robots that may or may not come out in the near future, if you look at self-driving cars and come back to this 2025, legal in the UK, available as taxis in San Francisco and various other cities right now. What is a self-driving car if it's not a robot? It's an AI robot. That's what it is. We may not see AI robots hitting us in huge numbers that are humanoid in form. They will be a major part of our life going forwards. I mentioned about the battle between these enormous general purpose AI models like GPT against the smaller, somewhat open source specialist domain expert models. And I believe that we see a rich future in that. And I would encourage people looking at innovative and entrepreneurial solutions using AI to consider how the rise of large language models and AIs that can run on small devices within 2 years could open up whole new fields and opportunities for tech and business creation. And lastly, to finish by saying, well, you're not going to get away from it. Whether you're interested in AI or not, we're all going to be using it. In fact, to be honest, we're probably all using it today in some form. It is going to be part of our lives in every way. AI is a foundational technology, just as the internet is a foundational technology. You can't get away from it. And I think, can we skip on? Okay, this is my last slide. Okay, AI is not a thing, it's a concept. So when somebody says, is that AI or is that machine learning? I don't know, it's up to you, really. Decide yourself. AI is not normal, it's probabilistic in nature. It will not come up with the right answer every single time, but it can do things that normal software can't. When you're planning your AI project, start with the return on investment. Don't do it just because it's cool. Work out if it's possible, and then work out if you should be doing it at all before you get started. Experiment early, get involved. The rate of change in this field is just ridiculous. I've been in tech my whole life, and it's changing every week, let alone every month. Disruptions everywhere, and build your own AI maturity. Build it for yourself, build it for the organization, because you will all benefit from it in the future. And that is me. Thank you very much.